Let's look at UV mapping in Maya at a very broad level. I've got a scene set up here where I've got a hand model, as you can see. I've got its UV map. I've got some UV map tools, and then I've just got my normal channel box over here. So what is UV mapping? Well, it's a way to take a 3D object and represent its surfaces in a 2D form. And the reason you want to do that is so you can, let's say, paint details on the surface. Those details, at least when you're using the UV method, have to be recorded in a 2D file, like a Photoshop file, a TIFF file, or something. It can't be just recorded as painting in 3D space. And so this representation here in the UV map editor, and you can find that here under UV editor, shows the layout of the UVs as they are now. So you can see that these UVs, so what we're seeing here are the edges. In between the edges are the faces, and the vertices are in here. You can select faces, but it's just a mess. So you can see when I select faces here, it selects faces all over the hand here. That means that there are lots of overlapping UVs. And why is it shaped like this upside down T? Well, that's because we started modeling this from a box, and whenever you create something, I'll just create a box here. There, I've just created a box, and you can see that its layout is like that. All 6 faces are unwrapped. So this box has no overlapping UVs. If I select a face here, it just selects one face here. Select another face, it selects that one. So if I wanted to paint on this one, I could paint on the surface or in a map, and I know that by painting in this location, it's not referring to more than one polygon. And so the painting would only be assigned, if I painted here, to some area on this polygon. Probably the most common reference that you know that has to do with something like UV mapping is our projections of the globes of the Earth's surface. So if you follow the belief of the round Earth, this is a problem, because if you want to represent the Earth's surface in a 2D image, you have to unwrap a 3D object and lay it out in some way that does not distort the representation of the objects on the surface disproportionately. And so you can see that people have tried many different methods, and the method that we even use to this day sort of maximizes legibility at the cost of deforming some of the most northern and southern land masses, for example, to overrepresent the size of Greenland and Canada and things like that, compared to those more the ones that are at the equator. But when we're working in 3D modeling, we have to do the same thing. We want to unwrap this hand, for example, in such a way that we can see its shape pretty clearly in the UV map, but without distorting the shapes too much. So let me get rid of this cube. So how would we start with something like this? Well, it all starts with the modeling. So if you know that you have to UV map something, and in addition to painting textures, the other reason for UV mapping, especially in biomedical communications work, is that sometimes we need to have distinct surface locations for putting things like particles on a surface. And so they rely on distinct UV map locations. So if, for example, we wanted to put a particle on the surface here, it's going to refer to its UV address. And so if we look over here, we've got what's called the 0 to 1 UV space. So this is the U direction along the bottom, and this is the V direction along here, and you can see it goes from 0 to 1 in this common coordinate system. You can see there are more quadrants, and these actually repeat forever in this space. But what we typically use is just this upper right quadrant of the 0 to 1 UV space. So with a model like this, we want to lay out the UVs to fit within this space in a sensible way. And so, for example, if this part of the hand in the UV map was sitting somewhere like this, then the UV space would be maybe 0.1 in U and 0.5 in V. But right now, if let's say I go and select just one face here, you can see that face is located at about 0.5 and 0.5. But if we sort of marquee select, to select more than one face, so I've got a whole bunch of faces right now, so you can see they're all over the model, but they all sort of occupy the same UV space. So if I were to say I need a particle at this location, Maya would find the UV space, but it would be confused because there are lots of faces at that UV space. So we have to lay out the UVs without overlaps. Okay, so let's do this for the simple model of the hand. And like I said, the first step is in the modeling. If I know I have to UV map this, I'm going to lay this out in such a way that it's going to be easy, or as easy as possible, to separate the model into different UV shells. So UV shells are separate pieces of, well, we can think of it like cloth. So if we're making a pair of gloves to fit this hand, how would we cut the material and where would we sew it together to minimize the number of seams while laying them out in a sensible way that would be easy to sew together? So for example, first of all, this is kind of a mess, right? So the first thing you usually want to do when you're UV mapping is project some UVs. So under the UV menu up here, you'll see that we've got automatic, and we can do one of these one after the other and it will just override the last one. So if we say automatic, it's going to make 6 projection cameras, and so it's looking at your hand model from 6 directions, and so you can imagine that from this point of view it's going to give you this shell and maybe some of the insides of the fingers that it can see, probably some of these up here. This point of view, it looks like is giving us the palm and part of the thumb here, and so on. So the benefit of this is you automatically get no overlapping UVs. The weakness of this method is you get a lot of separate shells, sometimes made of only one polygon. So that's not great. So we can go back into object mode and go to UVs, and let's say we try cylindrical mapping. And so we get this manipulator here. It looks a little confusing, but it's shaped like a cylinder, at least a half cylinder. And if you want to close it, you can grab this red handle and close it around, and you can see what's happening. It's as if this is the point of view and it's looking at the hand from all these directions, or the hand is being projected onto this surface, which is then unwrapped here. So this cylindrical shape is actually a deformed representation of this 0 to 1 UV space. So you can sort of see the hand here. There's the thumb and, the seam where these come together, because it has to be cut somewhere, right? It has to turn it into a 2D object. So this 3D shape has to be cut somewhere. It's where this edge meets here. So the seam is back here. Anyway, so there are still some overlaps here. And how can you see if there are overlaps? Well, one way you can do it is turn on this button here, and this shows one side is red, one side is blue. So the outside of the model will be blue, the inside will be red, and if they overlap, then you get a kind of purple. So let's see if we can get a perfectly red piece here. So if I just take one of these UVs and move it, oh, there's a little bit of red down there. Oh, probably here we can get it. Yeah, so this is the piece of cloth that we're using to make the gloves for our hand. Then the blue surface is the outside, let's say the leather finish, and the inside is the soft inside to cradle your fingers. And so that's the red part. the blue part is the outside, and where it's any sort of purple, that's where you've got overlapping UVs. Okay, so cylindrical, not good for this type of object. And there are other things like spherical, which obviously will not be good for a hand, but it works in the same way. But let's just look at the controls a little bit more. So you can see I can close this to change how it fits. If it's not closed, it's going to extend beyond the 0 to 1 UV space. And then this green handle can close it towards the poles here. So now we've got a sphere going all the way around our hand. It makes no sense. You can also, oh, this is new. Oh, you can rotate it this way. Interesting. So what this essentially is doing is moving the way it's projecting. And so you can see the map changing as well. This little, it's kind of hard to see here, this red T, if I just click on it, it gives us our regular manipulator handles. So you can actually move this around. You can scale it up and down. It doesn't make a difference in this case because it's still projecting inward from whatever direction. And we can also rotate it this way if we want to. Anyway, cylindrical, no good. So let's go back to object mode. And if you do go to object mode and you want to get that manipulator back, if you just hit T on your keyboard, nothing will happen. Okay. Oh yeah, so if you go into the spherical projection here, you can click on it on the inputs of the channel box and you can get back to it and you can do the same manipulations. But for something like the hand, probably a planar map is good. So let's open the options for this. So let's look at some of these options. So we want to fit the projection to the bounding box, and that's just the overall size of the object, its extreme limits. And we want to project from a certain axis. So I've mentioned before that it's always good to model in the middle of the world. There's no sense really modeling this hand on an angle, so you can see I modeled it roughly along this axis, and this is the palm of the hand is pointing in the Z direction, as you can see down here. So in this case, using the Z-axis is a good idea, but if you model cleanly like this and try to avoid modeling in a weird orientation or off the center or rotated or something, then your life will be easier to do something like this. So Z-axis, yeah, we don't need to create a new UV set. So you can have more than one UV map for an object, but we'll just use the basic one and we'll project. And there you go. So the first thing about this is that it looks like the hand. So if we wanted to know where different wrinkles were, folding lines, we could kind of get an idea from here where they're going to be. But the problem is that there's a lot of overlap still. So the front of the hand is overlapping on the back of the hand because this projection is just from a single plane. Now I know it's sitting right on top of the model, but if we pulled it out here, you get an idea that you can think of it either as the hand projecting onto this 2D plane or the point of view projecting from this plane onto the hand, but this face here is going to be largely overlapping with, this face here because of the point of view and the way they project. But this gives us a good place to start. So the next thing we can do, if we continue the glove analogy, is that we can start cutting and sewing this thing together. So the goal here is to get the fewest number of shells. Right now we just have one shell, and you'll see what a shell is a little more clearly in a moment. One shell of UVs we want to have the minimum number of shells. We don't want to deform the shape of this too much, and we want to minimize the number of seams, so the places we have to sew things together. So in this case, I knew eventually I was going to have to make UVs for this, so I made sure I modeled it with one edge that flowed all the way along here, over each finger, between the fingers, and so on, till it gets to the thumb. Then things get a little bit messy, because I knew that if I'm imagining the glove analogy again, I would take a pair of scissors and cut around and get two shells, one for the front, or one for the palmar, and one for the back of the hand. Dorsal? No, I can't remember. So to do this, I can select the model, and I'm going to go into edge mode, and I'm going to select the edge that I think is that one. So double click, and yeah, you can see this edge here flows all the way around until it gets to this part of the thumb where it doesn't know where to go from this point. So now I can just do the cutting, well, I can trace the path of the cut manually. So just holding down Shift, I'm going to click on some edges here. And when this will eventually be a seam, so you usually want to try and hide a seam in an area that is difficult to view because it can be visible in your texture maps. Oops. I'm on the PC instead of the Mac today, so I'm always pressing the wrong buttons. And I think I can double click here to get the rest. So it goes down here. So you can see I've got one edge flowing from one side to the other. Okay, so now what do we do? If we look in the UV toolkit over here, which is part of the UV editor, which again is found here, we can cut. Okay, so let's do that. So you may have seen that this edge seemed to change, and that's because this has now become a border edge between two shells. So if I want to, how can I do this? Okay, weird things happening here, so I'll just stretch this out a bit. So now these UVs are cut, and I just have to move them from being on top of one another. So there actually may be better ways of doing this now. The UV editor has changed a lot in the past few versions of Maya. But if I just select one UV, so instead of marquee selecting, because I can get some on both shells, I'm just going to click on one, and then if I hold down Control and right click, I can go to UV shell. Now if can we see this here? So in the hand model, you can see there are only UVs selected on the palmar surface. That's because my cut separated the front from the back into two shells, right? So now I can just hit W to go into move mode, and I can separate these from each other, and you can see where the blue and purple or blue and red are overlapping, we get purple. So now this is like looking at the inside of the back of the glove, so the furry lining. So we don't want that, we want to lay it out flat. So we can select just a few UVs on here, Control right click to UV shell, and then we can flip it. So here under, okay, this is all new. Under transform, we can go to flip, and we want to flip in the U direction. Yes. So now we've got, this is the back of the glove or the back of the hand. This is the palmar surface of the hand, but they're the outside surfaces in both cases. So if we get in close, actually, we can still see there's some overlap here. You know, my line was not really perfectly set up to avoid overlap. So some of these things you sometimes have to fix by hand by moving them. But there are other tools that allow you to do this too. So if we don't want to go through and, you know, manually get rid of these overlaps, which you don't want to do, because why would you want to do that? We can look here in the UV toolkit under Unfold. And again, these are new to me, some of these things, the way they work, but we've got Optimize, Unfold, Optimize Tool, and Unfold Tool. So let's look at what these do. And we'll just look at this shell, which is the back of the hand. So if I select a couple of UVs, Control right click, UV shell. If we click on Optimize, boom. Whoops. And so you can see it's trying to avoid any overlap. There's a little bit of overlap here. So when there's overlap between the same side, we'll get a dark blue, right? So you want to avoid that. But that's pretty good. So one of the reasons you want to avoid overlap is for painting and stuff. But if you, oh, look. Oh, if you just double click on a UV, it selects the whole shell. Okay, forget what I said before. Just click on a UV, double click, it'll select the whole shell. Well, that's pretty good. The other reason you want to avoid overlaps is some other programs like ZBrush and Mudbox hate overlapping UVs. And so these tools will help avoid that, but you just want to go and make sure. So I'm undoing this. Okay. Unfold. How's that different? I have no idea, but it looks a little different, right? Unfold looks like it's totally getting rid of all overlaps, but kind of deforming. It's pushing vertices apart, sort of or UVs apart in equal distance, so you get this kind of splayed finger sort of thing. So you can go between, try those different things, but you also have this thing called the Optimize tool and the Unfold tool. So let's see how these work differently. So Optimize tool, we'll go to the index finger. So now it gives you a brush, and you can brush over. And just like everything else in Maya, whenever you have a brush, if you hold down the M key and drag up and down, that controls the strength of the brush. Hold down the B key and go left and right, that will change the size of the brush. Right, so, okay, pretty good. Now, one thing that you want to avoid as much as possible is deforming the shape of the polygon. So this polygon here, for example, is represented by these 4 UVs. And in the 3D model, this polygon is connected by 4 vertices. And if the shape of this polygon changes drastically, the shape of this UV patch here changes drastically relative to the shape of the polygon. That is to say, if they don't look the same anymore, if this is actually a tiny polygon in the 3D space, but we make it a huge UV patch, then you'll run into problems, because let's say we paint a texture and it has to be a square texture that's going to fit into here. This UV patch is getting a lot more of the area of that painted texture than, say, this one here. But in reality, they might be sort of the same size polygon in the 3D model. So even though these tools are pretty good, you can start to deform the model in ways that could cause problems later on. Okay, so let's try the Unfold tool compared to the Optimize tool. I have to say, I don't know what the differences are between them. Could look them up, but you don't want to see me looking that stuff up. You can look it up yourself. At any rate, you can go through and use this to unfold and just spread out the UVs a little bit so we get a good representation. So the good thing about doing it with the tool rather than the action here is that it doesn't affect these ones at all, because these ones are laid out nicely as it is. So by using the Unfold tool, it would spread these ones out as well to some degree. By using the Unfold action, it would just apply this effect over the whole hand. The Unfold tool, we can just go and select where we want it to go. Okay, so let's do the same thing with this side. Double click. Now we know. And let's do the Optimize tool. I don't know. They seem to do largely the same thing. There's probably some subtle difference that people more proficient in UV mapping would know. Whoa. Well, that was a big jump. Why did it do that? Let's go to the Unfold tool and see what it does. So the Unfold tool is a little subtler there. Getting a little messy in here, but that's kind of a messy part of my model too. This whole thing is a little messy. So I kind of like the way the unfold tool works a little bit more than the optimize tool. You can see that my finger size is not really reflecting the shape of the fingers here, and that's because I was using the tools. So it's sort of disproportionately shrinking the fingers, changing the relationship. But anyway, it's good enough for now. So what's next? Well, we've got sort of a minimum number of shells here. We've just got 2, but we can maybe even make this into 1 shell. And would also minimize the seams, because we've got a seam going all the way along here. But we could, if we wanted to, sew together this side, so the pinky side of the glove, onto the pinky side of the back of the glove here, to make one layout. And you don't have to do this. In this case, I don't even know if it's worth it. But why not? We can try. So sometimes it's worthwhile trying to make a straighter edge where you want to sew things together, because otherwise Maya, if you do an automated process, is going to try to stretch these things to meet. But let's just look at one concept here, that even though this is an individual UV and this is an individual UV, these two UVs share a vertex. So we go into vertex mode, and if I select this vertex here, you can see it's also selected here. I'm just going to turn off my border edges. So remember, this is a 2D representation of a 3D model. And on the 3D model, there's just one vertex shared between here, because these edges are actually also connected. So if I select this edge, you can see both of these edges are selected. So when you make a UV map, you're just cutting along these edges, but in reality, this shape is connected here. So we're going to sew that back together, but let's grab some of these UVs. And I can use B on my keyboard to use my soft selection. And, you know, I could try to straighten this out a little bit. I'm not very good at doing this. There are some automated ways of straightening edges. Again, I don't want to deform the shapes too much. I'm just going to move them a little bit. So this is pretty much a straight edge here. Okay, so something like that. I'm going to do the same thing over here. Again, I don't want to deform the shape of these edges too much. Oh, that's terrible. That edge went all the way around when I double click that, because it's oh, I'm in vertex mode, sorry. So because I was in vertex mode, it was selecting them on both sides. Anyway, we can sort of straighten this out, and I'm not doing a very good job of it here, admittedly. But then let's say we select a bunch of edges, turn off soft selection. So now we've got an edge flowing along here, and you can see it's selected on both sides. And here under the toolkit, we can go to cut and sew. And we can say, oh, okay, this is new, hold on. There should be a move and sew tool. Let's see. So if you just do sew, it's going to stretch it out to meet. There is a move and sew, stitch together. Oh, it's called stitch together now. So stitch together, we'll try to move those edges close together so it's not stretching out these. So it used to be called move and sew. Anyway, now we've got some overlap here, so we could go back into our unfold tool, you know, and try and fix this up, maybe the optimize tool. Oh, okay, so now I've got to select UVs. So the unfold tool is just trying to evenly space these out and avoid overlapping. So So it's an ugly, weird looking hand. But then the last thing to do is whatever your UVs are, is they have to fit within the 0 to 1 UV space. So I'm going to rotate and scale them down. Now you want to sort of maximize occupation of this space. So it's, again, you don't really want to deform them too much, but I might want to stretch these up a little bit. And you have to avoid things like this, even parts where it's just going over the edge, because ZBrush or Mudbox will not accept these. So I just want to give it a little breathing space around the edges so it's not even touching the edge. So up there it's touching a little too much. So this is an ugly map, I'm so sorry. But you can try and clean it up a little bit, but the more you clean it up, the more you're kind of deforming things a little bit. You can, where is it? Move, no. Sorry, I had a bit of a tech hiccup there. But you've got cut and sew. You also have align and snap, and this is very familiar from any kind of graphics program. But so if I've got this edge of UVs selected, I could align them like this. I could do the same thing with these ones if I wanted to. Anyway, you don't want to deform the shape too much, but you want to have sort of tidy UVs. So everything has to fit within the 0 to 1 UV space. You want no overlaps. You want to have minimal distortion. The lowest number of seams possible. And you could argue that, well, maybe I can keep sewing. If I kept sewing like this edge to this edge and this edge, and I could sew the edges of, these things together. But then essentially you're making the 3D model again. So at some point you just have to leave it laid out like a flat shape. And so what this allows us to do now is if we go in and select a face, if we marquee select, it's going to select faces that are attached to each other. We're not getting overlapping faces anymore. Everything has its own unique location. So the 05 UV space is just here now. And those are the basics of UV mapping. There's a lot more subtlety to it, and we can talk about that a little bit more, but this will give you enough to think about when you start your models, how you want to model them to prepare for UV mapping in the future if that's necessary. And again, if you're not going to paint the surface or apply a 2D texture or have particles running over the surface of an object, then UV mapping might not be necessary at all. But for something like a hand, where you're going to have to paint details on the surface, different color for different areas, then definitely UV mapping is needed. There is another method for painting surface called PTEX that avoids the whole UV mapping thing, but it's not perfectly implemented yet. And so it's still necessary to learn UV mapping even at this stage. I don't like UV mapping, but it's not that hard. It's just a bit of a conceptual leap and lots of little tools to use, which, as you can see, I don't even know them all that well, but I can mess my way through it to get something somewhat useful. A real UV mapper probably looks at this and laughs as a horrible UV map, but for my purpose at least, it serves that purpose. Okay, thanks.